Okay, this is the second in the videos about data analysis and ourProbes. So first one was in ourProbes25, and in this one I carry on and have a look at the trending graphs and the Angular code behind that, and then have a look at the data extract. Part of data extract, I also want to show bring the data into things like Excel and how you can use it in applications like Power BI to do more full analysis and more interactive visualizations. So here goes. So following on from the last video, going to move on from the data analysis overview to the data analysis trends. Just a note here, from the overview you can get to the trends if you want to see a particular probe and device. So in this case I want to see our DAS probe running on device 2. If you click on that, it takes you into the trends with those probe and device set. And one difference between trends and overview is overview is looking at the raw measurement data, whereas trends is looking at the summaries of that measurement data. So one difference is the trends are the values for all the things that happened within that piece of summary data, so either for the last hour or for the last day, depending on what kind of summary it is. And also does not show the absolute latest measurement. So summary data is only produced every last hour or last day. So you may not see measurement data that you see in the overview shown in the trends for that last piece of time. Once you're in the trends tab, you've got parameters, you can see it. So by default I came in from overview where I was viewing the number of successful tests, so that's what it's set up for in trends when I came in that way. But for something like this it may be more interesting to see the bandwidth or bits per second that was observed and look at values like the percentiles. So 25th, 50th and 75th percentile is something I found useful to look at for bandwidth, just to see what sort of range of values they fall within. I'm going to remove count, that's not going to be useful for this view. One note here, you've got an auto scale y-axis, so it just brings the values down so that the y-axis starts at the lowest value. This is useful sometimes if you've got values that are very high but close together, you just want to spread them out to get a better idea of what they're showing. You can also do things like look over a longer period of time. So here we can look at 24 hours worth of data. Once you get into these very long ones like 30 days, it's going to look at daily values, summaries, rather than hourly ones. I've only got data going back about 10 days, so you don't see the full 30 days, but it is based on daily data. I'm just going to look at 24-hour data. And you can change things like the device. So I came in here as D02, but I might want to see what's happening from D01. So I see slightly different numbers. I can select a different probe. And again, I can select different things to view. So I may want to see things like round trip latency, which probably isn't so interesting for something like our DAS, because it's always within 2 or 3 milliseconds. So let's go in, look at the code that was used to produce these charts. Just before jumping into the DA trends code, just looking at how I implemented the click from the DA overview heat map over to DA trends. So actually I had to go up through the containing component, the DA analysis component. So in the DA overview component, when someone selects on a square in the heat map, it forms this code here. Basically sets up an object that has the trend settings I want to send to the DA trends page, and then emits an event from DA over. So DA over is contained inside the DA analysis component. It's one of the tabs in there. So it responds to that DA trend message or trend event coming in the back end, it processes that message. So among other things, it changes the current tab index over to the tab containing the trends component, and also sets up the local copy of the device ID, probe ID, and type ID, which are parameters for datrends, and datrends receives that information as input statements here when the datrends component first opens, and then from there that information is processed to set those up as parameters inside datrends. Okay, looking at the datrends code, again this is an Angular tutorial. I'll just go through the highlights of things that are a little unique to what I did in datrends. So like I showed before, gets inputs for device ID, probe ID, type ID to preset the parameters if there are any. Otherwise, all the selectors for the measurements are in this block of variables here, and then all the chart options in this block here, color schemes here. Otherwise, we get into the ng on init is the first thing that happens when we're going into this component. I think the most interesting thing here is setting the selected probe either based on the probe ID that was coming from the input statement. If there's none, then it just selects it to the first probe that's available in the system. Same thing for the device, either uses the device ID or the first device ID in this system. Also selects the type, so whether it's bits per second, successes, fails, those sort of things. Then based on that, it presets the series it shows. So again, this is the first time through, so if it's success or fail, then count is the interesting thing to show. Otherwise, if it's not success or failure, so things like round trip latency, bits per second, or time till first byte, then the 50th percentile is the more interesting initial thing to show on the chart. And it calls get chart data. Down in get chart data, interesting part here is it's creating the series that is, or the objects that's used by the ngx-charts from the measurement summary service. So measurement summary service get charts series just passes all the parameters, and then that returns everything nicely formatted as an object ready for the display in ngx trend chart or line chart. So here you can see the chart data has been set to what was returned from the service, and then the show chart is turned on to show the actual chart. Let's jump into measurement summary service. So here's the get chart series, and the interesting thing in here, which is something that's a little different. So again, just the normal getting the summary records that I want to get from measurement summaries using a big where clause, and I over in the Firestore indexes I had to set up an index to support this where clause. Then a snapshot changes, pipe that out. Okay, and here's some interesting stuff. So I'm using a map and then a reduce on the series. So a series was passed as an array of strings here. So again, the series are things like the count, bits per second, round trip latency. So the different types of series we can have one or more. So we do a reduce on that, and then we do a reduce on the actual snaps that was coming from this query. So you see there's two level of reduce here. So series reduce on chart multi-series series name, and then for each series it then does a reduce on the snaps that match those. And this is the way it creates the object hierarchy that's used by the ngx chart. So the list of, for each series it has a list of data points, and those data points are these things getting concatenated in the reduce statement here. So the name, which is basically the date, and the value that's coming from the snapshot data. Then we push each of those series onto the chart multi-series that we're building up in this reduce statement, and then we return that chart multi-series, which is in the format that's used by the ngx chart object. Otherwise, just a bunch of change statements, and then because I used subscribes in my component, when I leave the component, I just unsubscribe from those to make sure I don't leave those subscriptions in memory. I have a walkthrough of the data analysis extract functionality, so it's on the extract tab. It allows you to extract either the raw measurements or the summary measurements. So the parameters are shown here. So it has a granularity of 1 day, so you can't get any finer granularity than selecting a start date of a particular date. And like it says here, the start time for that date is the start of the day local time, and we'll see in the extract what that means. So I'm just going to choose data that's been produced today relative to the local time zone, so starting March the 8th. I'm going to get 4 hours worth of data, so with this setting it's going to collect data starting at midnight today and going 4 hours into the future from midnight, but I can select other periods if I want. I'll just get 4 hours data for this. I can extract different sorts of data. I can extract the hourly summaries, the daily summaries, or the raw measurements. So I'm going to select the raw measurements, and I can say how many rows I want to extract. I'm going to choose 1,000 because I think I'm going to get quite a bit of data, and I want to get all the measurements that are time to first byte, or TTFB measurements that are being produced by the probes and the devices. And I think we're ready to go. So getting 4 hours worth of data, I press extract data, says it found 379 rows of data. If I click on that, it downloads the data as a CSV file, and if I open up that, and opens it up in Excel, and we can see among other things, it contains what the local date and time is. So here is where we see that the data extracted is relative to the local time, so basically starting at midnight today on the 8th, but also shows the universal metrics time too, which is for me today 5 hours in front of my local time, so is showing the same data is reflected as a UMT date that's 5 hours in the future. I also split off the UMT hour and minute in separate columns. This makes it easier for analysis, I find, especially in Power BI, to do some of the drill downs that you need to work with the dates and the times in separate columns. Otherwise, it's just pulled out, because I requested the measurement data, a copy of the measurement data, so the device, the probe name, the probe ID, the type of data, because I just asked for the TTFB data, that's all it shows in there, the value for that data, and then the dates. So let's have a look at the code that does that, and then I'm going to jump over and have a look at using this data in something like Power BI to do more interesting visualizations, more ad hoc visualizations on the data. Now a quick look at the code for doing the extract. Nothing too earth-shattering up in the daextract HTML. The only thing that's really new is down here, this anchor tag, where it's picking up the parameters for href and download from the TypeScript file behind this, and this is the way it exposes the extract data for downloading. So let's have a look at the associated TypeScript file. I'll just start from the beginning up here. So just an on init section, and then this on extract is triggered when you press the extract button on the form. Shows a spinner, goes through, and then depending on the type of collection of data selected, whether it's the raw measurements or the measurement summary, it does two different processes for getting the data, because it's getting the data from different collections in the Firestore database. So one is get the measurement data, and then if it's summary data, it calls the get measurement summary data. Kind of similar here, gets the selected data, the data that was requested, and then goes through, subscribes to the data that was selected here. So in the subscription, as the data is coming back, it processes each row of the each document coming back from that collection. And this is kind of an interesting part here, is using the spread operator to create this object called big MD. So for things like, I wanted to get the dates in different formats. I found the native date that the UMT date is in. It's hard to interpret in external programs like Excel and Power BI, because it comes down as the number of seconds and number of microseconds or milliseconds since a certain date, which is hard for those programs to deal with. So I wanted to convert them to a more normally formatted date, and I wanted to have both the UMT date and the local date available. So I'm using the spread operator on the object that's coming back. In this case, it's the measurement data, MD data. So I do the spread operator on that to get all the properties for that object, and then add to it these additional objects to do with the date, which you saw in the demonstration is included in columns that is extracted. So it gets all that, and then once it's got all the rows, it calls create blob, and also so first it calls to CSV for the data coming back, and then it does the create blob. So let's have a look at those. So this is some code to convert an object coming in, or an array of objects. So all the measurement datas that have been created to CSV. I stole this off the internet somewhere. Seems to work. And then with that data that's now in CSV format, it does this create blob. So it creates this extract blob using the blob function, assigning it the data type. So I called it the data type of application CSV here, so that external programs can understand what's getting downloaded. And this is where it starts creating the properties for that anchor tag, so that when you click on the anchor, it actually produces a download for that blob of data. So here you see it sanitizes it first, so it can be read from the browser, and then it creates an object URL for that extract blob, so that all that is made into the file URL. I set the extract name to be just ourProbes the current date with the CSV, date and time with the CSV on the end, just so that each file created is unique. And then I turn off the spinner and show the anchor tag. I'm going to look at example of using Power BI with the extract function. So what I'm interested in is comparing the responsiveness of a certain website over from 3 devices, doing time to first byte tests on it. So I'm going to look back 3 or 4 days. Fifth is about 3 days ago. I'm going to get 7 days worth of data, but it's only get about 3 or 4, because that's all the data there is. I'm going to get hourly summaries and select 1,000 rows, and get the time to the first byte data. So I'm going to extract that data, and there's the data as CSV file. Now let's go over to Power BI, pick up that data and create a new visualization. Now I've opened up Power BI. It's an empty session, so first I'm going to get the data I need. So I'll go to More, select Text CSV, Connect, and that's the data I just extracted. I'll bring it in, and I'm just going to load it. I don't need to make any changes to the data. Okay, now all the data I just brought in, the columns in that data are shown here to the right. I'm going to select UMT date and P50 values. The thing I want to do for this UMT date is change it to just UMT date, not the date hierarchy, and also I want to change the chart to being a line chart. Still doesn't look too good so far, so what I'm going to do is add the probe name as part of the data and put the device into legend. And I'm just going to select this website to use for comparing data. Let's make this a bit larger. You can see already here we're getting three lines shown, one for each device. So device 1 and 2 is down here, and I'm getting about 2,800 milliseconds time to first byte times for the 50th percentile. But up here on the device 3, I'm getting about almost a full second more. Now device 3 is connecting over Wi-Fi, whereas device 1 and 2 is connecting our Ethernet connected devices. So I think that's probably proven out that when you go via Wi-Fi, the time to first byte is going to take longer, just because Wi-Fi is slower. At least my Wi-Fi is slower. You see a bit of variability between device 1 and 2, but just looks like, seeing they're changing places here, that there's no real difference here. They're in the same location. So in this case, that's kind of what you'd expect. So that's an example of sort of thing you can do with Power BI. You can make these charts look a lot nicer, change the headings, change the footings. You can do things like, so if I put in devices, something I can select, and if I'm just interested in D02 numbers, so we see the variability of that one device shown in more detail, just because it's not showing the other devices, so I can show the variability between 2,700 and 2,770. And we can do things in Power BI like go to the analysis tool and say add a trend line, so we can see whether the trend's positive or negative, in this case over about 3 days. There's a lot more trending and analysis you can do, but this is an idea of what a tool like Power BI or any other sort of data analysis tool can give you by having that extract data available.